Well, good morning. I hope everyone's doing okay. We're going to take a look at section 1.4. I've got some terms that we're going to take some notes on. Let me pause my music. Some terms we're going to take some notes on, and then we'll give you a few problems to start working on, and we'll finish that tomorrow as we go over the Zoom. So once again, I hope you are all safe and healthy and taking care of yourself. And if you have any questions, concerns, please shoot me an email. All right. Okay, well, let's get started. We're on 1.4, reasoning and proof. I'm going to get this off the double screen so we can just look at the paper. Reasoning and proof is the section, and it's on page, 45 in our book. All right, and so at the top of the page, you can see a term that says conjecture. Basically, all that is, it's just a statement that's believed to be true. It's a statement that you believe to be true. It's conjecture. Okay? So it's not necessarily fact, but it's conjecture. Conjecture. There we go. A statement believed to be true. All right. And then there's two types of reasoning, or kind of to prove the conjecture. You can use inductive, which we don't use a lot. That's kind of just like in paragraph. And deductive is what we use mostly, and it's called a two-column. It's like you make a statement and then you prove why it's true. You make a statement and you prove why it's true. You state why it's true. And so we use a lot of deductive reasoning or two-column proofs. Okay? A theorem is basically, this is on down at the bottom, page 45. It's a statement that can be true, that can be proven true. You know, if my son says he's made his bed, well, I can prove that true or not, and I can go show. But I can give a counter example, which is kind of an example which disproves a theorem or a statement. If I go up there and his bed is not made, well, that's a counter example. He said he made his bed every day. Well, there's a day that did not happen. Counterexample. A conditional statement is what we spend a lot of time talking about. We've already actually talked about it a little bit. They are if-then statements. And under if, well, what comes after that is usually the hypothesis. That's what you're suggesting. Okay? And if that occurs, then you have a conclusion. So if the hypothesis happens, then that would be the conclusion. Okay, and so, and many times it's if, like a statement and then the conclusion. For instance, right here at in the middle of page 46 at the bottom, actually, page 46 is a box of property of equality copy in the notes. That's what I want you to do. There's all kinds. You got the addition property. This is how we solve equations. Addition property, subtraction, multiplication, division, reflexive, symmetric, transitive, and substitution. But those properties are how we solve equations. Please copy those into your notes. You can pause the video. Okay, well, now you're back. Let's take a look at the idea of the linear pair theorem, which is on the top of the next page, 40. It's on page 48. A linear pair is a pair of adjacent. Now that's important. We know what that word means. Okay, adjacent angles whose non-common, meaning the ray that they don't have in common, whose non-common sides opposite rays. A pair of adjacent angles whose non-common sides are opposite rays. All right, so what does that mean? That means this, okay? Let me show you in a picture like this. Those, angle 1 and angle 2, are adjacent angles. The non-common here, and we can write them as two separate angles like this. There's one angle, and there's the second angle. These are what we call a linear pair. And angle 1 and angle 2 are adjacent. They are next to each other. They're not opposite of each other. Could be similar to your neighbor in your neighborhood, like the Botkins for the Bennetts are adjacent or next to each other. Okay, and so they also, we know that they add up to be the sum of 180 degrees because it makes a straight line. Okay, so then they're called supplementary. Okay, so a lot of terminology today. Linear pair. This is a linear pair right here. Two angles that are adjacent. That's a linear pair. Okay? And I don't know what adjacent means. They're next to each other. They're this is their common side. The non-common side are opposite rays. Okay? Sum of 180. All right, so let's use that then in a theorem. Go to the bottom, page 48. Take a look at example A. It says given RT is equal to 5x minus 12. We have a segment. Now this is going to use the segment addition postulate. Let me move this to the top of the screen. We have S somewhere here in the middle. We'll call it S. We got that R. We got that T. And we know that RS is x plus 2. And we know that ST is 3x minus 8. So with this information, I know that RS plus ST is equal to RT. Okay, that's called the segment addition postulate. We talked about it last week. Okay. RS plus ST is equal to RT. This angle, this side right here, from here to here, plus this side segment from here to here, adds together to give us the whole thing. So now I'm just going to substitute and put x plus 2 in for RS, substitution property of equality. I'm going to substitute 3x minus 8 and put that in for ST, 3x minus 8. And then that's equal to 5x minus 12. And then I solve for x. Let's combine like terms. I have x and 3x is 4x. 2 minus 8 is minus 6. Running out of room, so I'll come up here. I'm going to add 12, so I'll have negative 6 plus 12. And I'm going to subtract x. I'm going to have x over there. So it looks like I end up with x equals 6. Okay, now, what is the value of those lengths? Well, if I put 6 back in, that makes this segment 8. This would be 18 minus 8, which is 10. And if I add those together, I get 18. 5 times 6 is 30, minus 12, 18. Check. Okay, let's go to the next page. Let's do the same thing, but using the angle addition postulate. Okay, so these are not a linear pair. Now, not a linear pair. They are adjacent, but they're not a linear pair. Sometimes these can be hard to name or figure out what they're doing in these pictures. You got to be careful. RSP and T. Just need a C in there for some respect. Let's see. We know that this is x plus 25 because it has a little degree symbol. That means that's the measure of an angle. And this is 5x plus 10. measure of an angle. All right, and the given information says that the measure of angle RST is 15x minus 10. All right, and so if I add the measure of angle RSP plus the measure of angle PST, it's going to equal the measure of angle RST. Okay, all right, so now I'm going to substitute again. RSP is x plus 25. PST is 5x plus 10. And RST is 15x minus 10. Substitution, let's just combine like terms. We've got x and 5x, that gives us 6x. Takes care of those. 25 and 10 gives us 35. It's equal to 15x minus 10. Let's get the x's on the same side of the equation. And so subtracting 6x from both sides, 35 then is equal to 9x minus 10. Add 10 to both sides. 45 is equal to 9x. Divide by 9. And x is equal to 5. Okay, so let's make sure. Let's check it, make sure. If I put 5 in, 5 times 15, 75. 75 minus 10 is 65. That's the whole thing. Let's see. 5 plus 25 is 30. And then 25 plus 10 is 35. 35 and 30, does that add up to be 65? It sure does. Check. Okay. Last stuff. Let's talk about some definitions. This is on page 50. Page 50. Through any 2 points, there is exactly one line. Okay, so if I have 2 points, I can't put more than one line through those 2 points. Okay, that's that top page. Through any 2 points, there's exactly one line. Through any 3 non-collinear points, we kind of talked about this when we talked about a plane. It's usually denoted with like a parallelogram. Like that. 3 non-collinear points, there's exactly one plane. I'm just going through each example. If 2 points lie in a plane, then the line containing those points lie in a plane. So I'm going to use this picture again. If 2 points lie in that same plane, then the line that you would use is also in that plane. Makes sense. If 2 lines intersect, then they intersect in exactly one point. Okay, it's like an x-y-axis, all kinds of different lines. They intersect in a point. If 2 planes intersect, we kind of talked about this with the walls when they intersect. If 2 planes intersect, not a great picture because these should be dead. But 2 planes intersect, they intersect in a line. Think of the front wall and the side wall. Okay, let's get you started on some basic problems for homework. Again, this is just the start of it. We'll do more tomorrow. Okay. Let's go page 53. And we're going to go 5 through 12. That'll be a good start for us. 5 through 12. Okay. Let me see if I can get back onto this screen. You can see it okay. I don't know if you can see it or not. Sometimes it comes up, but it doesn't. But tomorrow we have a Zoom. I'll send out the invite at 11. Well, the Zoom's at 11. I'll send out the invite on Canvas, so you have to be able to access Canvas in the morning. Probably at around 9:30, 10 o'clock. And we'll have a Zoom tomorrow. We'll do more of the same. Okay? All right. Take care. Hope everyone's safe.